quickly because, of course, I want to get to the exciting part. Okay. So number one, why should you bother with this, right? What is the point of studying machine learning and data mining? Now, I could tell you that it's fascinating and it happens to be what I do for a living, but I'm biased, right? So why should you believe me, okay? So what I say is like, don't believe me, believe these people. Here are a few quotes, and there's many more like this, that should at least, tell you that there's something going on. And you're probably already aware that machine learning is a very hot area in computer science these days, but you may not be aware of just how hot it is and, why it's important. So let's spend, a little bit of this first class on that. So here's something from a guy you might know. His name is Bill Gates. And he says, a breakthrough in machine learning would be worth 10 Microsofts. That would be the world's first multi-trillion-dollar company. I think he's guilty of understatement. We'll see why shortly. But hey, if it's worth 10 Microsofts, there might be something in it. So DARPA is this famous, agency, right, that funded the internet development and a lot of other great things in computer science and other areas. Tony Tether, who was until a few years ago the director of DARPA, says machine learning is the next internet. Right? If it's the next internet, maybe it's worth knowing about. John Hennessy, who's actually a well-known computer scientist, but these days is the president of Stanford, says machine learning is the hot new thing in computer science. Prabhakar Raghavan, who was until recently the director of research at Yahoo, but since I made this slide, it's already outdated because he's been hired by, I think, Microsoft or Google, one of those. Web rankings today are mostly a matter of machine learning. You might not know this, but every time you do a search and get results, you're using a machine learning algorithm. Greg Papadopoulos, another famous guy in information technology, he used to be the CTO of Sun, now he's a venture capitalist and other things. He says, machine learning is going to result in a real revolution. These are people who are, not necessarily, very likely to engage in hyperbole. Jerry Yang, founder of Yahoo, machine learning is today's discontinuity. Technology and, civilization advance not, as a linear progression, but by making sudden, huge leaps. And he says machine learning is the one that's happening today. Steve Ballmer, another guy you might have heard of, says machine learning today is one of the hottest aspects of computer science. Okay? So clearly there's a lot of ballyhoo about machine learning. What is the ballyhoo about, right? What is this thing called machine learning and why is it so important? It's traditional, right, to start a class by defining the subject and, I'm going to fall for the same thing, right? At the end of the day, you will know much better than you can say in one sentence what machine learning is. But for now, let's just try to do that. And I'm going to do this definition in 2 words, right? It's not one sentence, it's 2 words. Machine learning is automating automation. What we as computer scientists do is automate everybody's job and make them unemployed. Yay. Oops, no, that's not what I meant. What we do as computer scientists is we make things possible that weren't possible before. Because it would take 1 million people to do them, and we don't have those millions of people. With computers, right, we can actually do the work of 1 million people with 1 CPU. And so all sorts of things that were completely impossible before become possible. Like computer games and, right, just imagine if somebody was actually painting each of those pixels by hand. Okay? So the power is in automating things. The more we automate things, the cheaper they become, the more people that can have them, and so on and so forth. Okay? But here's the question. Who automates the automation? Right? As we automate more and more things, perversely, the bottleneck becomes us, the computer scientists, the software engineering, the information integration. That's what's slowing us down. So this is what we want to do. We want to make the computer science, the programming, the software engineering process itself be automated. Right? So here's the picture. Computer scientists put everybody else out of jobs. Machine learning people put the other computer scientists out of jobs. Hey, that might be a good reason to learn machine learning, right? And then you'll still have a job and no one else is left standing. Okay? And it's also very ethical to steal from the thieves, right? Then 2 minus is canceled, and we're very nice people. Okay, so joking aside, how are we going to do this, right? This sounds very good, but how do we automate automation, right? We have to get computers to program themselves. This is the idea in machine learning, is that we're not going to program the computers. We're going to get the computers to program themselves. So I always say to my students, if you're lazy and stupid, come work with me. If you're smart and you're hardworking, you can do systems, you can do software, programming languages, networking, security, graphics. All of that stuff is for the smart people. We in machine learning are dumb and we're lazy. We want to push a button and have the algorithm do the stuff for us, and then we go to the beach. And we're still making a lot of money and whatnot, right? So that's the agenda. Getting computers to program themselves. So how are we going to do that, right? Think of all the smarts that you put into writing software, right? Can we actually get a computer to do that for you? That's the agenda, right? We want to replace this bottleneck of writing software where all the, person's, months are now going into, the thing that's keeping us from going further, and have the computers do that themselves. And then maybe things can take another leap to happening even faster and on a larger scale and so forth. So how are we going to do that, right? This sounds like, well, sure, beautiful dream, but how's that going to happen? We have one secret weapon to make that happen. And it's because we have that weapon that all of this is possible and wasn't before. And that weapon is data. We're going to let the data do the work for us. And as you heard, this is the era of big data, right? There was that McKinsey report, like some months ago saying, we are now in the era of big data. We need 150,000 people who have expertise in analysis of big data. And what we have right now is like 1% of that. We're going to take that data, right? And it's by sucking all the juice out of that data that we're going to have the computer automatically write programs that otherwise would take a lot of work on our part, or even better. We might not even know how to write those programs, but by running machine learning programs on data, we'll actually have them. We'll see some examples of that. Okay? So that's the idea. We're going to take data and turn it into programs. Now, even with that, you're probably still thinking, well, this sounds too good to be true, right? So first of all, we can do this in some cases, but not others. And as the research progresses, we'll be able to do it in more cases. But even with the small, simple, at some level programs that we can, create today in this way, it's amazing what you can already do with them. And, we'll see some examples of that shortly. But nevertheless, you might still be justified in having some skepticism, okay? So let's see a little bit of how this is done, right, before we dive into the details. Here first is the picture of traditional programming, right? This is what we all know and love, right? This is what we do for a living. There's a computer, data and the program go in, and out comes the output that you want, right? And our job is to write the programs inside, is to write these programs that then go inside here and combine with the data to produce the results. Okay? So this is what we all do. Machine learning is turning that around. What machine learning does is it just switches two little things in this diagram. The output is now the input, and what was the program, what was an input, now becomes the output. The output is now at the input, and the program is now at the output. You see what this is doing? What this is doing is the machine learning program, right? This is what the machine learning is going to do, is that it takes in the data, the raw data that the program is going to have to operate on. And then the desired output, right? We just give the computer examples of what we want it to do. And then hopefully, on a good day, if the machine learning works and you can get it to work, then from the examples of the input and the output that you want, you can induce the program that should be running on the computer. Okay? And then once you have that program, guess what? Then you put it in there, and now the same old thing happens. Okay? But the beautiful thing is that you didn't have to write the program yourself. Or the long, hard exercise of writing the program became a much easier exercise of just controlling the machine learning to make sure that it does what you want. Okay? Here's a metaphor for what happens. Not everyone likes this metaphor because it's very low tech, but I actually think it's a very instructive metaphor. And the metaphor is this, is that machine learning is a lot like gardening or agriculture, right? What could be, lower tech than agriculture? Why is that? If you think about it, in all the artifacts that we have, cars, houses, TVs, computers themselves, right? We have to put them together piece by piece. We have to create the nuts and bolts from the raw materials. We have to assemble the nuts and bolts into subsystems and those things into the systems, right? This is a ton of work. It's a ton of work, and it doesn't scale, because the more complex the system becomes, the harder it becomes to actually put it all together without making mistakes and whatnot. Okay? compare this with what happens in gardening, right? Gardeners have a very easy life. Nature does most of the work for them, right? The gardener just provides the seeds and the nutrients and a little bit of care, and then from that you get, flowers, plants, trees, right? Or agriculture gets, your wheat and your corn and your rice and so forth. Okay? So this is a very smart thing to do if you can, right? Let something else do most of your work for you. You just provide the elements and a little bit of, tender loving care. So this is what we actually do in machine learning, right? In machine learning, the seeds, right? If you think about it, in your beautiful plant or flower, all the information is already in the seed, right? All that then happens is that seed sucks up nutrients and, outgrows the beautiful thing. So our seeds are going to be the algorithm. Of course, the seed by itself is not a plant. You need to feed it. It needs water, it needs nutrients. This is where the data comes in. The data is our nutrients. You're going to feed that seed with a lot of data, with a lot of nutrients, and then the programs will grow. Your job is to manage the whole process, make sure that the plant doesn't die, or if it dies, you plant another one, and so on and so forth. But it's much easier to do that than it is to, assemble a whole plant by yourself, molecule by molecule, right? That would be a very hard thing to do, but yet this is actually what's happening while the gardener is asleep. Okay? So keep in mind this metaphor, as we go forward. I think this kind of illustrates well why machine learning is potentially so powerful and such a great thing for lazy people like us.